Hello. Hello and welcome to this video. So in the last video we solved till question number 15. We will try to go till question number 30 in this video. So grab pen and paper and let's work through all the questions. Make sure that when I'm reading the problem you pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. Do not spend more than 15 minutes on a single problem. Okay. Now, without further ado, let's get started about the PDF. The link will be in the description for download, and I'll show you at the end how to download the PDF. So question 16 says that if NC12 is equal to NC8, find NC17 and 22CN. So we substitute the values in the formula, we get n factorial by n minus 12 factorial multiplied by 12 factorial is equal to n factorial over n minus 8 factorial into 8 factorial, which gives us n minus 12 is equal to 8 and n minus 8 is equal to 12. So n will be 20. And now we have to calculate NC17, that is 20C17. We substitute in the formula, we get 1140. We also need to calculate 22C20, that is n, which will be equal to 231. Question 17 says that if 18CR is equal to 18CR plus 2, find RC6. So there seems to be some typing mistake. This should be 8, should be here. So 18CR is equal to 18CR plus 2, which is equal to 18 factorial by 18 minus R factorial into R factorial is equal to 18 factorial by R plus 2 factorial multiplied by 16 minus R factorial. So this gives us 18 minus R is equal to R plus 2, that is R is equal to 8. And R is equal to 16 minus R, that is R is equal to 8. So two equations both give the same value. Now we have to calculate RC6, that is 8C6, it will be 28. Question 18 says that if n minus 4 is equal to 15, find n. So once again, we substitute in the formula, we get the equation n into n minus 1 into n minus 3 is equal to 3 into 4 into 5 into 6. So n is equal to 6. Next question says that if 15CR is to 15CR minus 1 is equal to 11 is to 5, find R. So once again, we substitute into the formula. We get fifth again here is a typing mistake, which 5 should be to the power here. So we get this ratio from the question. We substitute into formula 15 factorial by 15 minus R factorial into R factorial multiplied by R minus 1 factorial into 16 minus R factorial divided by 15 factorial, which gives us R is equal to 5. Question 20 says that if NPR is equal to 2520 and NCR is equal to 21, find R. So we are given that NPR is equal to 2050, that is n factorial by n minus R factorial is equal to 2520, and NCR is equal to 21, that is n factorial by n minus R factorial R multiplied by R factorial is equal to 21. So we substitute the value of this from here to NCR. We get 2520 by R factorial is equal to 21. So R factorial is equal to 120. That means R is equal to 5. We substitute back into the formula for NPR. We get N is equal to 7. Question 22 says that, 21 says that prove that 20C13 plus 20C14 minus 20C6 minus 20C7 is equal to 0. So we know from formulas that NCR is equal to NCN minus R. So 20C13 will be equal to 20C7 and 20C14 will be equal to 20C6. And that is why the given expression is 0. Question 22 says that if NCR minus 1 is equal to 36, NCR is equal to 84, and NCR plus 1 is equal to 126, find N and R. So we have NCR minus 1 is equal to 36, that is N factorial by N minus R plus 1 factorial. This should be factorial, and R minus 1 factorial is equal to 36. NCR is equal to 84 is equal to N factorial by N minus R factorial in multiplied by R factorial is equal to 84. And from the last, we have N factorial divided by N minus R minus 1 factorial multiplied by R plus 1 factorial is equal to 126. So we divide first two, we get N by R by N minus R plus 1 is equal to 3 by 7. That is 3N is equal to 10R minus 3. And we divide the last two, that is this and this. We get R plus 1 by N minus R is equal to 2 by 3. So 2N is equal to 5R plus 3. So we have two equations, two unknowns. We solve, we get N is equal to 9, R is equal to 3. So now the easy problems are done, and now the questions are still easy, but they require some more calculation. Question 23 says that how many numbers of 4 digits can be formed with digits 1, 2, 3, 4, 5 if repetition of digits is allowed? So 1, 2, 3, 4, 5 are there, okay? So 5 different numbers. The 1000 place can be filled in 5 ways, 100 place can be filled in 4 ways, because repetition is not allowed. So once we pick one number for 1000 place, it cannot be picked for 100 place. Tens place can be filled in 3 ways, units place can be filled in 2 ways. So the total number of 4-digit number is 5432, that is 120. Or alternatively, you can straight up apply the formula 5p4 is equal to 120. Question 24 says that how many numbers, there is again a mistake, between 400 and 1000 can be made with the digits 2, 3, 4, 5, 6 and 0 with no repetition. So you see, hundreds place can be filled in 3 ways, excluding 0 to 3. Tens place can be filled in 5 ways from remaining 5 digits. And units place can be filled in 4 ways. The number of numbers would be 4, between 4 and 1000 will be 5 into 4 into 3, that is 60. Question 25 says that find the number of numbers between 300 and 3000 that can be formed with the digits 0, 1, 2, 3, 4, 5 with no repetitions. So first we consider the number of 3 digits. So 100th place can be filled using 3, 4, 5, that is in 3 ways. Tens place can be filled in remaining 5 ways, and units place can be filled in 4 ways. The total number of numbers of 3 digits is 60, 5 into 4 into 3. Now we consider the second case when the number is of 4 digits between 1000 and 3000. The thousandth place can be filled in 2 ways using 1 and 2. 3 remaining places can be filled in 5p3 ways, that is 60 ways. The total number of 4-digit numbers is 120, and therefore total number of numbers is 60 plus 120, that is 180. Question 26 says that how many number of 4 digits greater than 2300 can be formed with digits 0, 1, 2, 3, 4, 5, 6 with no repetitions? So case 1, when 2 is at thousandths place. Hundreds place can be filled in 4 ways using 3, 4, 5, 6. 2 remaining places can be filled in 5p2 ways, that is 20 ways. So number of numbers in this case is 4 into 20. Okay, so 2300. Thousandth place can be filled. Then there are 3 ways remaining. Okay, 3 places remaining. This is not 2. Okay, 2 at thousandth place. So hundredth place is there. That's all right. It's all right. So when thousandth place is occupied by 3, 4, 5, 6, we see that there are 4 ways to fill the thousandth place. Remaining 3 places can be filled in 63 ways, that is 120. The number of numbers formed in this case would be 4 into 120. 4 comes from here, 4 ways. So 120 into 4, 480. So total numbers is 80 plus 480, that is 560. Question 27 says that how many number of numbers can be formed by using any number of digits 0, 1, 2, 3, 4 with no repetitions. So first case is when the number is one digit, there will be four positive numbers excluding 0. The second case is when the number is of two digits. Tens place can be filled in four ways using 1, 2, 3, 4. Units can be place can be filled in 4p1 ways, that is 4 ways. So total number of ways is 4 into 4, 16. When the number of three digits, hundreds place can be filled in four ways because like it can't be filled by 0. Remaining two places can be filled in 4p2 ways. The total number of numbers in this case is 4 into 4p2, that is 48. And the number is of four digits. Thousands place can be filled in four ways. Remaining three places can be filled in 4p3 ways. The total number of numbers, four-digit numbers, is 4 into 4p3, that is 96. When the number is of five digits, again 10,000 space can be filled in four ways. Remaining four places can be filled in 4p4 ways. The total number of the numbers in this case is 96. We add all those, we get 260 as the answer. Question 28 says that how many number of four digits can be formed using the digits 1, 2, 3, 4? Find the sum of those numbers. The total number of numbers will be 4p4. So we have 1, 2, 3, 4 and 4 digits and 4 numbers. So 24. Now since there are 4 digits and 24 numbers, each number will occur at each place for 6 times. Therefore, sum of digits at each place would be 6 into 1 plus 2 plus 3 plus 4, that is 60. And therefore, sum of all numbers would be 60 into 1 plus 10 into, plus 100 plus 1000. That is 66,660. Question 29 says that find the sum of all four-digit numbers that can be formed with digits 0, 1, 2, and 3. So when any digit except 0 will occupy in its place, the thousand place has to be occupied by two other digits. Thus total number of such numbers is 3 into 2 into 2p2, that is 12. Thus four numbers for each of positive digits. When one of 1 to 3 occupies thousand place, total number of numbers is 3 into 3p3, that is 18. Thus, 6 numbers of each of the positive digits. Sum of digits at units, tens, and thousands places will be 4 into 1 plus 2 plus 3 is equal to 24. And sum of digits at thousands place will be 6 into 1 plus 2 plus 3 is equal to 36. Thus, sum of numbers would be 24 into 1 plus 10 plus 100 plus 36 into 1000, that is 38,664. So this was moderately complex problem. If you don't understand, let me know in the comments and I will try to explain further. Question 30 says that find the sum of all four digits that can be formed with 1, 2, 2, and 3. So in this case, each of the four digits occurs at each place in 3p3 by 2 factorial, that is 3 times. Thus, sum of digits at each place is 3 into 1 plus 2 plus 2 plus 3, that is 24. And therefore, sum of digits is 24 into 1 plus 10 plus 100 plus 1000, that is 26,664. So, with this, we come to the end of this video. I know I went a bit fast, but these are still relatively very easy problems. As we progress further, there will be more difficult problems. In any case, if you don't understand any of the solutions, let me know and I will try to explain it further. Okay. In the comments, I will try to explain it further. And I hope that you are finding this playlist useful and informative. So thanks a lot for watching the video and I'll see you in the next one tomorrow with 10 more problems. Thanks a lot for watching again. Enjoy.